This is May 16th, 2020, and I'm doing a commentary on Religion Explained by Pascal, The Evolutionary Origins of Religious Thought. But really, before we get to the evolutionary origins of religious thought, we've got to get to the reality of thought itself, and the general part of it. This third chapter is a fairly complex chapter. The section we're on is called Architecture and the Designer. Our inference systems may be there because they provide solutions to problems that were recurrent in normal human environments for hundreds of thousands of years. So the brain we have, the one that we live with, actually, that created the inference systems, they were created for our nomadic ancestors, not for our urban-dwelling, highly cooperative, present modern system. So he gives an example, like a sweet tooth. Most of us have a sweet tooth. We like sweets. And that was developed in a time when sweets were rare. And when you ran onto one, you dove right in. But now, of course, we've created a system where there's just too much sugar and too much sweet. And so the sweet tooth of solving our ancestors' problems is not solving our present-day problems. Okay, so detecting what makes people reliable for cooperation is not the same as detecting what makes potential sexual partners attractive, which is not the same as evaluating whether a certain food is poisonous or not. So those are just three problems that our ancestors had, and to a certain extent we have them too. Detecting who is cooperative, detecting evaluating food sources, and we are, as he says a little later on, we are generalists. We adapt to different environments, and we do that by adapting our diet. We are omnivores. We eat pretty much anything, except there are a number of things that are really bad for us. And so a system for detecting what's bad for us sort of became a necessity. There are different ways of handling information. We could have a file of everything we ever experience, every animal, every whatever. The problem is that is not a very efficient or fast system for detecting, especially if we have a predator in our view and we need to get out of there. If you're going through a whole file of former experiences of particular animals, that encyclopedic file is not a good way to get to the information. So what developed was an inference system that quickly told us that it's an animal and a predator. And that's kind of a subsystem, an inference system. We would probably accumulate lots and lots of such specialized subsystems, thereby making the system a whole lot bigger and smarter. Being smart consists of having lots of specialized systems to handle rather than having a general purpose system that sort of files everything away. The sensory input that the mind gets is just overwhelming in terms of, so the mind had to have some way of the brain had to have some way of separating all that stuff. If, for instance, our facial recognition system kept specific files of each individual animal we ever encountered, this would both waste resources and make a rather sluggish system when we needed a quick answer if there was a predator in our, as I have mentioned. Ever-increasing specialization as the origin of complex cognitive capacities. That is what happened. Smarter species got smarter by having more instincts than other species, not fewer. But this was biologists who were making these conjectures, and they were just conjectures at the time. They could only assume that the evolutionary facility of multi-specialized systems, they could only assume that that was an evolutionary good thing for the individuals and for the evolutionary, the reproductive evolution of what happened, rather than having a system that filed everything away and retrieved it. We developed a system of specialized subcategories. But that was, for biologists, that was a conjecture. And it was a conjecture until it began to be compared with the findings of developmental psychologists, neurophysiologists, and they began to develop an understanding of inference systems that was very specific. So one could now combine psychological finding with the evolutionary background. This became known as evolutionary biology. And it justified the observation of the biologists who said there was evolutionary positive effects for the species in having these inference systems, these subsystems that worked quickly to infer things so that one could act in a very specific way very quickly. This required the connection and combination of evidence from evolutionary biology, genetics, neurophysiology, psychology, and anthropology. So it was a sort of an integration of all of those social sciences all at once. Now, the next section is evolutionary psychology. He has a very complicated goal paragraph on the goals of evolutionary psychology, but I think the goals are better described by the examples than they are by their particular principles, which are quite abstract and wouldn't mean much in this context. Don Simons and Dave Buss have put together a precise account of many aspects of human sexual behavior. How people choose partners, what they find attractive, as well as how they gauge the reliability of those partners for a long-term cooperative arrangement for child rearing. So these are the beginnings of evolutionary psychologists beginning to show biologists how those inference systems, which the biologists more or less saw, but they couldn't justify in an evolutionary way. Life in ancestral environments was fraught with danger. There are obvious predators, but also a variety of microbes, viruses, and toxins. The food they were getting they were scavenging from all over, and it was natural. Natural is more of a positive word in our situation, but in this case, natural means they can be full of things that aren't good for us, or good for them anyway. Again, we are a generalist species. That is, we can live in a lot of different environments and we adapt to them. We adapt our diet, our clothing, our whatever we need to do in order to live in a very different situation. Cognitive adaptations to minimize the danger of contamination and contagion. There is a system or systems that are very much concerned about the problem of toxins, and of course our ancestors didn't have microbiology or microscopes, so they couldn't really see things. But listen to this. Morning sickness seems to target precisely those foods that would be of danger to fetal growth. Interesting, huh? Evolutionary positive thing happening there. Even morning sickness. Pregnant women develop very specific food aversions, and those aversions are for things that aren't good for the fetus. Paul Rosen, who has studied the psychology of disgust, came up with three things principles that were sort of operating in those subsystems, those inference systems. These inferential principles. First, the toxin or the problem is not necessarily visible. You look at a rotting corpse, you don't see the microbes that are going to cause the toxic problems. So the visibility was an issue for our ancestors, and so when they saw something that looked a little icky, they just didn't eat it. Second, the contagion system assumes that even limited contact, however brief. Now, these are all things that are just, going off like a light bulb in this pandemic time. We're going through the pandemic of COVID-19. But second, limited contact, however brief, transmits the whole risk. So that idea there is no idea of dose effect. If you're in contact with it, it's all or nothing. And third, the third principle was any contact with sources of pollution transmits it, although the adverse reactions are particularly strong for ingestion. And they did experiments where they had a cockroach in a glass, and they took the cockroach out and they disinfected the glass, put water in it, and a number of people would not drink from it. They were disgusted by the presence of a cockroach in that thing, even though it had been disinfected. So contact with sources of pollution transmits it, period. End of story. I'm not going to deal with it. So our multitudinous reaction to the COVID virus has been one of where some people are just simply not going to have anything to do with it and shouldn't. Contagion inference system may have some circumstances that seem overly cautious. And when subjects in Rosen's experiments refused to drink from a glass that had had a roach in it. But the system was turned to ancestral conditions under which there was no such thing as thorough disinfecting. So we can thoroughly disinfect, but they could not. Okay, this is a complicated chapter, and we're going to go on, but the next section he calls Life in a Cognitive Niche, and he says there are really two things that human beings have to have that were developed by our ancestors, really. And human beings need information about the world around them, and they need cooperation with other members of the species. And this is very specific to us as humans, and we will talk much more about that tomorrow. Anyway, take care. Have a good day.